She's not in here. I got a few people here. Oh. Oh, and look at that, Kyle. You already got 2 likes on there. Oh, we got 3 likes. 4 likes on. Who else is here? How are these things getting this many likes? I only see it says 2 people watching now. Yeah, whatever. We'll figure it out. I know it's more. Cool. I'll get started in a couple of minutes. I'm just giving people time to kind of get into the chat. It says 2 for you. Well, it says 4 for me. That's weird. See, he forgot it. That's all right. Oh, sorry, I'm stretching. Where's my notification squad? People should get notified that these things are happening live. So, for you guys that are here, what do you think? Do you think we are actually going to go back into the real-life school building this year? Or have you not been, or have you completely tuned out from the news or something like that? Because I have no idea what the heck is going on. Hopefully, but probably not. Oh, okay, I see what you mean by hopefully. Yeah. I don't know. It was like week 1, and I was doing one of these live streams. One of my students said to me that they had never missed going to school so much, and it was week 1, and right now we're in week 3. All right, you still think it's a possibility? I mean, honestly, I don't know at this point. Yeah. Yeah. You guys aren't seniors, right? Aren't you guys seniors right now? Anybody here? I never know what grade people are in. No, you're not, Kyle. I know that. See, now I'm doubting myself. Now I gotta go check. Okay. Okay, hold on. If you guys are replying in the chat, I can't see at the moment. I'm on Genesis. I'm just confirming that Kyle is not. Kyle's not a senior. I'm doubting myself. Yeah, Kyle, shut your face. Yeah. Okay, he's a senior. Yeah. Yeah, I'll know, Kyle. I was just in Genesis. Anyway. All right. Okay, so here's how I'm going to handle it today. This video is going to have, it's going to start with some review problems from simplifying rational expressions. And then at some point, I am going to go into some new material that I'm going to introduce with graphing. We're going to get into it on that end. It's going to be phenomenal. Mainly for me. I don't know about the rest of you, but, you know. And then after the fact, if you need to review this video for any reason, it is going to have those timestamps in the description. After the fact, of course. So, send out the alerts. Send out what you got to do. Get people onto this stream as quickly as you can. Oh, my daughter sent me a picture. Sorry. I'm talking to you and I'm trying to live stream at the same time. There we go. But here we go. Let's get this thing moving. So, in the last video that I did, we talked about simplifying rational expressions by means of multiplication, division, and addition, subtraction. So I kind of wanted to go over a couple of them, just as a little refresher. I want to make sure I pick a good one here. I have my textbook that I'm picking problems directly out of. And I want to make sure I get a good one. Oh, that's a good one. Let's do that one. All right. So this is just going to be, I'm going to start off with a review of simplifying rational expressions. I would suggest watching this video is one thing. Trying it on your own is something else entirely. If you're watching this video after the fact, of course, you can always pause it before I go over a problem, knowing that you tried it on your own beforehand, because, of course, you're going to have to be able to do these types of problems. But anyway, here's a problem that I got. Example, directly out of the textbook. I got an x squared minus 16 over 3x to the third plus 18x squared plus 24x times x cubed minus 4x over 2x squared minus 7x minus 4. Yes, Kyle, you can pause it if it's a live stream, but then it's like, now you gotta catch up, and now you can't, like, chat live and all that stuff. You know, it's a little bit of a hassle. So I'm going to do one problem with multiplication, division. I'm going to do one problem, well, maybe a couple problems. I'll do a few problems with addition, subtraction. And then I'm going to, at some point, get into the new stuff. If during this you guys have questions or clarification needs or anything along those lines, please, by all means, ask me as I take a sip of my coffee. Oh, just as a reminder, your projects, I am currently working through your projects. Your projects are going to count towards the 4th marking period. Nothing we can do about that. We're in the 4th marking period right now. Can you believe it? Oh my gosh. What a world we live in. Anyway, let's get moving with this. So I'm looking at this problem, and I know that I have to simplify it. There's a whole bunch of stuff going on. There's two fractions being multiplied together. I don't have to flip anything because it's not division, it's multiplication. So I'm going to... Yes, it does. I know it does. But we're going to have to simplify somehow. So my first step, what do? How do I handle it? How do I go about this? Your first step, as was back in Chapter 4, Chapter 5, whenever we get a quadratic, whenever we get anything that's a higher level polynomial, you want to factor. Factor, 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 factor. So, you have 4 pieces to this problem. Top, bottom, top, bottom. You have 4 pieces to this problem. Let's take them one at a time. If you were to go through a partial Tucker method with x squared minus 16, you would find 2 magic numbers of positive 4 and negative 4. Nothing's going to simplify. So this ends up becoming x minus 4, x plus 4. And again, you can review the Tucker method through my factoring quadratics video that I did the other week. I'll probably have to repost that link at some point, but anyway. Now, we're going to run into a little bit of an issue with the bottom left and the bottom right. We'll deal with those in a moment. Bottom left and bottom right, we'll deal with it. Look at the top right. It's not a quadratic. I still have to factor it. First step of the Tucker method. The first step that mostly people skip over because they don't even think too much about it. GCF. You're going to need that GCF. There's no number that they both have in common, but they both have a variable in common. So, what I'm going to have to do, I'm going to have to take out an x. Now it's quadratic. Now, I'm going to have to factor that in a little bit. Let me separate this just so you can see they're clearly separated from each other. I'm going to have to factor that in a bit more. But let's just see what happens. Bottom left. Now, bottom left, there's a couple things going on here. First of all, they both have a variable in common. Not only do they have a variable in common, they also have a coefficient in common. You can also take out a 3. 3, 18, and 24 are all divisible by 3. Taking out a 3x is in your best interest. If you divide all three of those terms by a 3x, you're left with x squared plus 6x plus 8. Yes, we're gonna have to factor that farther. Oh. Hold on, I hear it. I'll be right back. Okay. Okay. I apologize for that. If you're still there, I wholeheartedly apologize. If you can hear my little darling girl right here, she's calming down. She fell out of a bunk bed just a few minutes ago. Oh. Hey, you want to see what I'm doing? You want to see what I'm doing? You want to say hi? Say hi. Oh. What did you land on? Did you land on your hands? Where can you point to where it might hurt? Right there. Okay. Was it scary? Oh. Okay, so yeah, that's why I was out of the room for a few minutes. Not that I would just completely abandon. Oh. Ellie, you want to see me do some math? Okay. Let's do some math then. You want to hold this? You want to hold this? What's his name? You don't remember? His name is Gengar. Oh. Alright. Ah. Oops. I get it. I get it. Take this. Alright. Ah. Okay, so that was fun. So I'll explain to you what's going on in the Markey household. Um, my son is currently live streaming with a friend. Um, he has been live streaming randomly with friends, just playing with them, doing like online play dates. And so he's in his room on the computer, or there's a little Chromebook, and he's having a blast. His sister, who is almost 2 years old, was playing on the top bunk, but wanted to see what her brother was doing. So she like leaned out way too far over the bunk bed and fell. We have no idea what she landed on. I think she's more scared than anything. Um, but yeah, thus the life of a teacher at home. You know, anyone ever see that video of anyone ever see that video of the reporter for BBC, and he's doing a live stream for like some BBC news report, and then randomly the door opens and it's like his kid runs in the room doing something, and then his wife is like crawling in the room trying to get the kids out. Anyone ever see that? It is super hilarious. Oh, look, there's Joe. Yeah, Kyle, like my wife watched that and just bust up laughing multiple times. But like that's the life of working at home with like multiple kids. That's the realest I can be with you right now. Oh goodness. So Joe, I don't know if you just came on from before, but this is only the first example. We've been delayed a little bit because my daughter decided to skydive without a parachute. I guess is the proper phrasing. Oh man, what a world we live in. What a world we live in. Anyway, I'm sorry. Let's go back to this problem. Yeah, Joe, I know. Oh gosh. Well, Joe, just for the sake of argument, my daughter about 5, 6 minutes ago fell out of the top bunk of a bunk bed. She's 2 years old. She is a daredevil. Let's just put it this way. For those of you that are watching, some of you know that I have two kids. My son, who in a few weeks will be 6 years old, he is a very cautious person. He will test the boundaries. He will practice various steps and whatever it is that he's trying to do. Um, and then eventually, once he believes that he can do something, he'll try it. You know, it was walking, for example. He would like stand up and practice and fall down and practice and stand up and sit down and all this stuff, and then you never saw him like try to walk and fall because he didn't do that. He didn't want to try something that he couldn't do. And then eventually one day it was like, boom, he's walking across the house. Like, where did this come from? Whereas my daughter is not that way. My daughter is more along the lines of, watch out, here I come. She doesn't care if she can't do something. She's gonna try it anyway. Um, the other day, I caught her. She's 1 year old. She's not even two yet. The other day, I caught her climbing up on top of the coffee table and practicing jumping off. Why are you? Oh my gosh. Just jumping. She can't land. Like, gosh. Anyway, back to math. Again, if you're watching this after the fact, I will put timestamps, as I said, in the description so that you won't have to wait for 3 or 4 minutes of silence while I go comfort my daughter. After I do this problem, I'm going to go check on her, but I'll do that after I finish this problem. Oh my gosh, what a day. Anyway, let's talk about this. The bottom right of this problem, I am going to have to factor using the Tucker method. There's no GCF that I can take out. So just as a little side note, kind of like a sidebar over here, sidebar, I'm going to have to factor 2x squared minus 7x minus 4. A times C gets you a -8. your two magic numbers would be -8 and +1, because they have to add up to -7, and they have to multiply to -8. I put a 2x and a 2x in the top of that fraction. Or top of that t-bar. I will eventually have to treat them like fractions in order to simplify. Again, this is the Tucker method from way back when. 2 over 1 doesn't simplify. Keep the 1 on the bottom. 2 over 8 does simplify. Keep the negative on the bottom. 2 over 8 becomes a 1 over 4 with that negative there. On the bottom of this fraction, it's really an x minus 4, which you can see right here, and a 2x plus 1. Now, unfortunately, again, nowhere near the end of this problem. We still have to factor. We still have to do the Tucker method with this quadratic right here, and we still have to do the Tucker method with this quadratic right here. So let's do that in the next step. I'm just rewriting the parts that have already been factored. I don't have to do them. On the bottom left, that 3x is indeed still there. But this will become an x plus 4 and an x plus 2. Because 2 times 4 is 8 and 2 plus 4 is 6. Again, that's a Tucker method basic problem, so to speak. On the top right, this would become an x minus 2, x plus 2, if it were factored correctly. On the bottom right, it's already been factored. I'm just going to write my factors out. Now, not at the answer yet. I'm not at the final answer yet, but of course I'm at the part where I have factored everything that I possibly can. Yes, Joe, there are sub-notifications. Once you subscribe, you can click the bell. If you click the bell, then you'll get an alert every time I go live or something like that. Which is great. What do you mean, no? Sorry, Joe's asking a question now. Announce in chat that's not... Oh! I got you. I understand what you're saying now, Joe. I do. No, unfortunately, I don't have that yet. I believe I need to be monetized. In order to be monetized on YouTube, I have the right number of subscribers. I have way more subscribers than I need from my YouTube days back in the day. But I need 4,000 hours of watched content. Right now, I think I'm at about maybe 200. It's like 4,000 for the year or something like that. Yeah, so I'm about 5% of the way there. Once I get monetized, then people can donate whatever the heck they want. I mean, to be fair, I mean, like, I know. To be fair, like, if I keep doing this, I mean, who the heck knows? Oh, yeah, Joe, I got a ton of subscribers. Did you not know I was famous on YouTube like 10 years ago? I'm sorry, I gotta finish this math problem. Joe, you're getting me distracted. Goodness. Pencils. Anyway, I gotta cancel junk out. Because everything is being multiplied or divided, I can start canceling junk out in the following fashion. This x minus 4 and this x minus 4 mutually cancel each other out. This x plus 4, this x plus 4 cancel each other out. This x plus 2, this x plus 2 cancel each other out. Furthermore, this x and this x cancel each other out. In order to cancel each other out with multiplication division, you have to be exactly the same term. Now, it's important to note, because this x minus 2 and this 2x plus 1, they are not the same term. And since they're not the same term, they do not cancel each other out. That's what we get. I have 4,000 hours, and then it took me a year to get 2,000. Well, sorry. But yeah, this is what we got. Now again, I'm reviewing a little bit of multiplication division. I want to focus more on addition, subtraction right now. Again, I apologize for the delays. So what I'm going to do is this. I'm going to put up two basic problems on adding and subtracting rational expressions. Actually, no, I'll do a basic one with you, and then I'll put up two that I want the viewers to try on their own. But I want to do the first one with you. So, let's do... I don't know if I want to do that one. No, I will do that one, because I can. Yes. So here's an example. I'm going to do the first one with you, and then I'm going to allow you an opportunity to try these on your own. Or try one on your own. Maybe two on your own. 5 over 6x minus 18 minus x minus 1 over 4x squared minus 14x plus 6. There we go. Yes, Joe. Kyle has a pencil for you. Kyle, give him the pencil. Anyway, back to this. So I'm looking at this problem. It's an addition-subtraction problem. In order to go about this problem, I'm going to need common denominators. They clearly do not have common denominators. I just need an hour to find it, right? They clearly do not have common denominators. So what does one do? First, as always, factor. Every single lesson in this chapter, your first step is always to factor. And that's exactly what we're going to do with this problem. There's a GCF that I can take out right here. Now that left fraction is completely factored. Now, there is a GCF I can take out here, and I want to do that real quick. There we go. I just wanted to take that out for myself just so I can kind of see what the heck is going on with the bottom part of that fraction. I take out a GCF, and I get a quadratic that I can do the Tucker method with. Now, to kind of speed ahead a little bit, if you did the Tucker method as a sidebar with that, you know what? I'll just do it over here. 2x squared minus 7x plus 3. A times c is 6. Two magic numbers are -6 and -1. T-chart with a 2x and a 2x. There we go. Just again, you could do that Tucker method as a sidebar. It's not part of the main problem, but it's something that we need to recognize. There we go. So again, first step is to factor. One thing I would note, that within each individual fraction, nothing cancels. Always double check for that. But here's what we need to recognize between the two. They both have an x minus 3 in common. This fraction on the left is missing a 2x minus 1. They also have a coefficient of 2 in common. They only have the 2 in common. This fraction is missing a 3. Where's my red pen? I need my red pen in order to do this step. I don't think I have my red pen. Oh, there's a red pen. Good. So here's what we do. I'm writing this in red so you can see it clearly. But the fraction on the right would have that same coefficient if things were being multiplied by a 3. Ah, the red pen. On the left, they would have the same denominator if everything was being multiplied by a 2x minus 1. And again, I'm putting this into the problem so that you can see it clearly. Is it the red pen or a red pen? It's a red pen. I have like a billion red pens. I love red pens. Right. But now, if you notice, look what happens when I do this multiplication. On the left, it'll have a 6, it'll have an x minus 3, it'll have a 2x minus 1. On the right, it'll have that 6, once that multiplication is done correctly. It'll have the x minus 3, it'll have the 2x minus 1. They have common denominators. That is the point. In order to add or subtract these fractions together, you need common denominators. So, ultimately, now I'm going to keep it separate for the time being, but the common denominator would look something like this. That's literally what it would be, because when you add or subtract fractions, the denominator stays the same. Now, on the top of the fraction, we have a little bit of an issue. On the top of the fraction, I have some simplifying to do. On the top of the fraction, yes, this 5 is going to be distributed. On the right, something will be distributed, but it's not just a 3. You got to realize that it is a negative 3 that is being distributed into the right side of the problem. A negative 3 is being distributed into this side of the problem because it's, well, subtraction sign 3 times. So I'm going to get a 10x minus 5 minus 3x plus 3. Ultimately, the top of the fraction simplifies to be 7x minus 2, which cannot be factored. Always double check to see if you can factor farther. And the denominator, well, you don't have to do anything other than write it. Again, something may end up simplifying from the top to the bottom. You just have to be ready for if and when that happens. The skills that you are learning in these first couple of sections are going to come into play for the new information that I have for you soon. So please be aware of that. All right, now I would like to give you a couple problems to try on your own. If you're watching, you can try a couple of these problems and see how you kind of do with it. So I'm going to give you a couple to try. Then I do have one that it's a much more fun problem, if I say so myself. But let's see what we got here. Okay, first example that I want you to try, and I'm going to split my page because obviously you're trying both of them. 4 over 3x plus 8 over x cubed plus 2 over 5xy. For this problem, for this first example, you cannot factor. There's nothing to factor, so don't worry about that. But you have to find common denominators and then simplify the rest of the problem. Now I have one more for you to try. And again, I'm going to give you a few moments to give this a shot. I'm going to go check on my daughter and see how she's doing. But let me see. I'm going to give you one more. Oh. Yeah, we're going to try that one. 6 over x squared minus 2x minus 35 plus 4 over x squared plus 9x plus 20. Yes. Take a few minutes. You need to try these two problems. On the left side, you cannot factor anything, so don't worry about that. Go about finding a common denominator right away. On the right side, you're going to need to factor both left and right sides of this problem. I'm going to go check to see how my daughter's doing, see if there's any blacks and blues, see if we can offer her some, I don't know, something. I hear I think she's watching something with Frozen. I think she's watching Olaf's Frozen Adventure. I don't know. I'm going to go check. Anyway, be right back. I'm back. Oh, you don't know what's happening. Hold on. Oh, what's happening? There's a lot in the chat now. What is going on here? Oh. Okay. Who's the answer? No, not fair. How's everyone's spring break? Yeah. Yeah. Oh, Animal Crossing. Fantastic. I'm just gonna flat out say it. We got Animal Crossing. My son's been playing, and my wife and I played back in the day, and we've been helping out. Um, okay. Uh, Animal Crossing is this weird game where you have to. Well, you're kind of forced into purchasing a house that you can't afford. As Kyle just said, you're constantly in debt, and then you have to sell things, collect things off the island, and then sell things in order to earn money called bells, and then you pay off your debt. And then when you pay off your debt, he's just like, "Hey, you want a bigger house?" And you're like, "Oh, sure." And then you get into more debt, and then you have to pay that off as well. Um, it's a really interesting, intricate game. It's like there's no end to it almost. It's just collecting. Anyway, so let's do these two problems together. Um, Joe, you say the year just started? We're in April, dude. We're almost halfway through the year. Anyway, we're a quarter of the way through the year. Let's do this first problem. This first problem, we got 4 over 3x. They have a 3 and an x. Okay. Then there's an x cubed. X times x times x. Yeah, 3 months is a quarter of the year. Anyway, then we have a 5xy. Now, something to notice, they all have an x in common. They all have an x in common. But this one in the middle has an x cubed. So in order to do this problem properly, these other two are going to have to be x cubes as well. This last one has a y, which means all 3 of them are going to need to have y's. This first one has a 3, which means all of them are going to have 3. This last one has a 5, which means all of them are going to have 5s. Here's what it comes down to. You need to see what each denominator is missing. What is each denominator missing in order to be the same? Let's start with the x squareds here. Or no, not the x squareds here, I'm sorry. Let's start with the first fraction here. This first fraction is missing a 5. Ooh, I'm going to write it in red. First fraction is also missing an x squared because you want it to be an x cubed. It's also missing a y. When multiplied out correctly, this should give me on the bottom a 15x cubed y. Let's go to this one. It's missing both the 3 and the 5. So I'm going to have to multiply that thing by 15. It's also missing the y. When all is said and done, that fraction in the middle will have a 15x cubed y. Let's go to the last fraction. It only has an x. I would like it to be an x cubed. So I'm going to multiply it by x squared in order to get it to be that x cubed. But it's also missing that 3. It's a weird problem. Because I did it this way, each denominator will end up being 15x cubed y. All 3 of them. It's a really weird problem, but I love it. Then I just have to simplify stuff. See what happens. The first fraction will end up being a 20x squared y. The second fraction, what is that? I want to say 120. Just going to double check. Yeah, 120. Plus 120y plus the last fraction, 6x squared. As terrible as that looks, that indeed is the answer. That's the answer, whichever way you slice it. You can't simplify that anymore. I mean, you could try to take like a GCF out of the top if you wanted to. which you'd only be able to take out a 2. You can't do anything else from there. Let's go to the second problem. Yeah, it does look gross, but I love it. Let's go to the second problem. Second problem, step 1. Step 1, factor. If you factored it correctly, you should have gotten that as the first fraction. Second problem, if you factored it correctly, you should have gotten this. Again, this is just the Tucker method over and over and over and over and over again. Notice that they both have an x plus 5 in common. They both have an x plus 5 in common. You can't just cancel them out. These are two fractions being added and subtracted together. You need a common denominator. So, this first fraction is missing an x plus 4. This second fraction is missing an x minus 7, multiplying top and bottom by the same thing in order to not change the value. When all is said and done, because I did this multiplication, they would have a common denominator of x minus 7, x plus 5, x plus 4. You need that common denominator. I still need to simplify the top of the fraction. The top of the fraction, yes, I'm going to have to distribute. And because it's a plus sign, I don't have to worry about it being a negative 4, thankfully. But I get a 6x plus 24 plus 4x minus 28. Ooh, something interesting might happen. I don't think it will, though. Yeah, I don't think it will. Let's just see what happens. What does this simplify to become? This becomes, what, a 2x minus 4 when you put everything together? Yeah, I tried to refactor the top. And when I refactored the top, nothing ended up simplifying. That's terrible. But that's the problem. Again, oh, you know what? I totally screwed that little part up. Totally screwed that little part up. I'm going to cross that out and be mad at myself for days. It's a 10x. Still, nothing ended up simplifying, but it was a 10x up there. Sad days. I can still factor out, what, a 2? And this becomes 5x minus 2, but still nothing ends up simplifying. It's just one of those silly clerical errors up there. Oh, fun stuff. Again, with the problems that I assigned you guys to do in your latest assignment. Oh, sorry, I'm reading emails while I'm talking to you. In the latest Google Classroom assignment, I just had you doing the multiplication division problems. I am eventually going to get you to do these addition subtraction problems as well. And then we're going to have to figure out some kind of assessment. And the assessment that I am going to do, it's going to be nice. I don't think... I'm going to be doing an online assessment, obviously. There's nothing I can do about that. I'm going to do 1 through quizzes that it's going to be, you won't be able to use any, like, photo math or anything like that. And there's going to be 1 through link it as well. Can we go over multiplication division problems? Joe, yes, we can. I went over a multiplication division problem probably before you got here. You know what? I'll do 1 more multiplication division problem for you. I want to make sure I get the right one. Ooh, I know what to do. Joe, how about this? Since you want to go over a multiplication division problem, I have 1 more problem that I would like to go through that involves everything. It involves everything. It involves the multiplication, division. It involves the addition, subtraction. Let's do that one. And this will be before I get to the new information. Slightly new information. I'm going to introduce something today. It's going to be great. So, bear with me. You're going to try this problem out. And Joe, it's going to answer your question, and it's going to try everything all together at once. So here's the big example for this morning. 2 over x minus 1 plus 3 over x minus 4. The whole thing over... I'm waiting for Kyle to kind of freak out at this point. 6 over x squared minus 5x plus 4. There's the problem. It looks amazing. There he is. Because Joe asked a question. That's why. Joe asked a question, and I decided to answer his question with this. It's going to be amazing. So, Joe, in terms of multiplication division, it's much more straightforward than addition subtraction. With addition subtraction, you definitely need common denominators in order to bring things together. With multiplication division, you need to factor everything out and then see what cancels out. She walks away for like 2 seconds. Anyway, so this problem encompasses both ideas: multiplication, division, addition, subtraction. We have to do the addition, subtraction first. Now, this long division bar divides the problem up in a big, big, big way. We're going to temporarily ignore the bottom part of that fraction. We're going to ignore the bottom part of that fraction temporarily, and then we're going to come back to it. I'm going to have to find a common denominator for the top part. So for the top part, there's nothing to factor. But in order for them to be a common denominator, I'm going to bring out the red pen. I'm going to need to multiply this by x minus 4 over x minus 4. And this is x minus 1 over x minus 1. So, if I do that, the top of this fraction, or I'm sorry, top of this fraction, the bottom of this fraction is going to be an x minus 1, x minus 4. The whole thing is divided by this junky thing down here. We'll deal with that in a little bit. I may need a new marker soon. Good thing I took a bunch. Anyway, let's distribute that 2. Let's distribute that 3. Again, if you notice, I'm ignoring the bottom part. I'm just dealing with the top part of this fraction. 2x minus 8 plus 3x minus 1. I can simplify that a little bit. Let's move it down over here. I'm going to move that whole part over here now. That would become a 5x minus 11. Terrible. Over x minus 1, x minus 4. Now notice I'm doing this. I am changing that big, giant division sign to a division symbol. We'll deal with that in a minute. But that thing is being divided by that part that we ignored before. Again, I just want you to look at this whole problem. Look at this whole problem for a moment. The bottom part of this fraction we just ignored temporarily. We ignored it temporarily. We brought it over here, ignored it. Brought it down here, ignored it. The only thing that we've been working with so far has been the top of that fraction, which were 2 fractions being added together. You need to find a common denominator. Do that proper multiplication. I wrote that out in red. Simplify the top of that fraction. I just brought everything down here. Now, Joe, this goes to your question. You asked if we can go over a multiplication division problem. Here you go. See, we're not done with this problem yet. The only thing that we've done so far is we've taken care of the addition subtraction. We still have to take care of the multiplication division. So, I could do two things. I can take care of that division sign. Kyle's going to wrap it for us, but what do we have to do to take care of that division sign? That big giant division sign right in the middle. Oh, he's off the ball. He's not answering the question then. Kyle, what do we do? Don't make me say it for you. Wait, hold. What? Hold up, what? Yes, Mary. We keep change flip. Oh, that's fun. Anyway. Now I'm going to keep change flip, but I'm also going to factor at the same time. We're definitely going to keep change flip. Oh, he got the link in there just in time. But with this whole keep change flip thing, because we have to take care of that division of fractions, that 6 is going to end up on the bottom of the fraction. We'd have to factor the top part of this right here, this x squared minus 5x plus 4, which would become an x minus 1, x minus 4. So everything's multiplication division now. We can cancel out this x minus 1. We can cancel out this x minus 4. Oh, we're left with a 5x minus 11 over 6. This giant, terrible monstrosity up here ends up becoming this itty-bitty fraction down here. What fun. What fun. I enjoy it. What if you can't cancel them out? Well, Joe, great question. Let me show you the first example we did today. It should be earlier in the video, but I figure it's a good time to review that. Joe's question is, what if we can't cancel them out? Well, we did this problem earlier, and this was the original problem right here. This whole thing right here was the original problem. And we had to, well, factor everything. We factored using the Tucker method. We factored using GCF. I did a little sidebar Tucker method over here. I had to factor things down a little bit more, and you can see what canceled out. Well, looky right here. This x minus 2 on the top and this 2x plus 1 on the bottom don't cancel. Neither does this 3 over here. Since they didn't cancel, and everything's being multiplied, top times top, bottom times bottom, we just brought them over to our answer. Similar thing happened on the problem that we just did. On the problem that we just did, there we go. On the problem that we just did, well, the 5x minus 11, nothing canceled it out. The 6, nothing canceled it out. We just brought them over because things were being multiplied. Top times top, bottom times bottom. Remember, when I say cancel each other out, I mean that x minus 1, they just became a 1. That's all that thing became. Strange. Very strange. Okay. Now, obviously you have that Google Classroom assignment. And you're going to be dealing with that Google Classroom assignment, and that is due at some point today. Again, I'm not grading it on correctness. I'm not grading it on correctness. I'm grading it on completion. I want to see what you guys can do. It's not going to be a grade that counts as like a major or minor or anything like that. Not at all. Not yet. Because you're just learning this information for the first time this week. I think it's due a half hour ago. Hold on, let me double check. No, it's due at 2 o'clock. It says 2 p.m. And 20 of you have turned it in. Yes. But it's just practicing these problems. Oh, for me it's at 11 a.m.? That's weird. That's very weird, Kyle. Yeah, I always have them usually do it like 2 o'clock. Unless there's, I don't know, unless your computer is set to some weird Eastern Standard Time. I don't know. Anyway, here's what I'm going to do. I'm going to suggest to you right now that if you do not have a graphing calculator, that is perfectly fine. Well, that's true. I can have it for different times per student, but I usually just do for everybody. Why would I purposefully mess Kyle up and keep everyone else the same? I wouldn't be that much of an evil person. Yeah, I left that open. Anyway, if you don't have a graphing calculator on you, I'm going to type a link. Maybe you did. I'm going to type a link into the chat right here. And you can, and you've probably already gone to this website before, that's perfectly fine. But if you've never gone to Desmos before, you can sign in using your school Gmail account. And you can follow along with some of the graphs that we're going to be doing here today. Unfortunately, I can't show a live shot of, well, you do. Yeah, you do. I know you have the fancy one. But if you don't have one, obviously, you can still go to Desmos and get this thing done. So this is actually, for notes purposes, this is section 8.3. Now, I'm only introducing this today. I'm only introducing the basic concept today. Eventually, I'm gonna have to do another video on. More advanced equations. In this sense, we'll be fine. So what I'm gonna do. Let's see, which one do I want? I'm going to put up an equation and then I'll be right back. Yeah? Yes? Hold on. Let me write the equation. Sorry, it's my son knocking at the door. Give me 1 sec, bud. I'm going to put a function up here. If you have a graphing calculator, please type that into your graphing calculator. It's y equals. Otherwise, you can type it into Desmos, and I will be right back. What's up, bud? What's Mom and Ellie doing?
On the table.
Okay, I will help you print a picture in a moment. Okay, let me just see something here. I will be right back, James. I'm just going to shut this down. I'll be right back. Okay. I do. Nice. I do have to, unfortunately, end this stream at this point. I need to go take care of some things family-oriented. There's my son. If obviously you knew earlier, my daughter fell off the bunk bed. She needs help. Anyway, I know you're all freaking out at what this looks like, but here's the thing. This is a wonderful preview for you all. How do I clear RAM on Calc? Clear RAM second plus sign 712. But anyway, yeah, I thank you guys for hanging out for the time that we had. I will have to schedule another live stream soon in order to go over this with you. And again, I do apologize for ending this stream a little early, but yeah, we're all good. See you guys later.